In this video, we'll begin to look at 2004 AB2, which is an area and volume problem. It is a calculator problem, so we will use the graphing calculator on this. So it starts off with f and g are the functions given by f of x is 2x times 1 minus x, and g of x is 3 times x minus 1 times square root of x on the interval from 0 to 1. Graphs of f and g are shown in the figure above. Find the area of the shaded region enclosed by the graphs of f and g. So on a free response question, the first thing that you have to do is you have to set up your math correctly. In this case, we're going to set up an integral to handle this. And it's going to be very simply the integral from 0 to 1. Now, we might often have to solve for points of intersection, but in this case the points of intersection are fairly clear at 0 and at 1, and then it's just top minus bottom. You don't have to write all the functions specifically out, since they define f of x and g of x. We can simply write this way. Now that's all the work that's required, and then you can solve this on the graphing calculator. So we'll bring up the calculator now. So you can see that I put in the two functions. y1 is 2x times the quantity 1 minus x, and y2 is 3 times x minus 1 times the square root of x. And if we were to graph that, and I set the window from -2 to +2 for both x and y, we can kind of get a picture that looks like the picture in our in the problem here. But that's not going to help us. We're looking for the area. So what we need to do is to subtract the first from the second. So let's take a look at how we would do that. So what I'm going to do is leave the two that are there alone, and I'm going to set up a new function, which is y1 minus y2. So I go to variables, then to y variables, then to y1, then minus variables, y variables, function, and y2. Now I'm going to turn off the other two functions, and we do that by placing the cursor on the equal sign and toggling it. So you can see it's unhighlighted, which means it doesn't show up there. Now when we go to graph, we'll get this shape, which happens to be the same area as the area in our in the original problem. And now all we have to do is second, calc, 7 to find the integral from 0, enter 1, enter, and we get 1.133 rounded to the to 3 decimal places. And that's all the work that's needed to be shown for this particular part here. We have to set up the integral correctly. We can use f and g since they're clearly defined in the problem. We don't have to write out all the math. We certainly don't have to simplify anything. Just set up the integral and then use our calculator to solve it. What we don't want to do in here is we don't want to put integral from 0 to 1 of y1 minus y2. We don't want to use calculator speak. We want to use the math speak here. I will go on to the next part. Okay, so I'm going to go on to another window here. If you still need to look at this one, you can pause. Otherwise, we'll start on a new screen. Okay, then in part B, we want to find the volume of the solid generated when the shaded region enclosed by the graphs of f and g is revolved around the horizontal line y equals 2. So the first thing that I have here is I'm going to draw this line y equals 2. Now it's not exactly, it should be higher, but because when I revolve this whole thing around y equals 2, I'm going to need a lot of space for that. So this is not going to be necessarily drawn to scale. And the first thing that I'm going to do then is I'm going to revolve both of the curves individually around the line y equals 2. And so revolving the line f around that would look something like what I've drawn here. And again, remember how we did that was we just took a representative strip from the line y equals 2 down to the curve f of x, and we spun that around the line y equals 2. Then next we would take a representative strip going from y equals 2 all the way down to g of x, and then we're going to spin that around the line y equals 2 also. And that might look something like this. So we can see we're going to end up with a washer here. And the washer is going to have a little bit of thickness, which is the dx. So recall with the washers, what we have is we're going to find the area of the between the two rings. And what that amounts to essentially is just taking the area of the outside circle minus the area of the inside circle. So we call the radius of the outside circle capital R and the radius of the inside circle little r. So our area formula would be pi capital R squared minus pi little r squared. And from that we can begin to set up the integral. We bring out the pi, we're going to integrate from 0 to 1, and it's simply capital R squared. So here's the trick in this one. The length of the radius of the outside circle here is 2 minus g of x. And then we're going to square that. So that's capital R. So if we wanted to write down capital R is 2 minus g of x. And little r is going to be 2 minus f of x. And so we'll have 2 minus g of x quantity squared minus quantity 2 minus f of x quantity squared dx. And again, what we really need to do here is set up the integral first, and then the rest of it's going to be handled by the calculator. So I'll bring in the calculator and show how we could use that to set this up. So we already have our two functions in there, and we have the y1 and the y2. Now we can go in and adjust y3 if we wanted to. Might be the easiest, but let me put in a new function here instead. So I'm going to start with pi, and then I have parentheses. I'm going to put in two parentheses so that the pi is applied to everything. And I'm going to have 2 minus g of x is y of 2. y2. So it's vars, y vars, function, y2, quantity squared, minus, open parentheses, 2 minus variables, y variables, function, y1, which is our f of x, close parentheses, squared, and close parentheses again. So I have pi times that function, 2 minus g of x quantity squared, minus the quantity 2 minus f of x quantity squared. And I'm going to turn off the other function, come into graph. Now you can't necessarily see all of it, but that's okay. Second, calc, option 7, and the lower limit is 0, upper limit is 1, and it's going to shade all that in and give us 16.179. So once again, we need to set up the integral. If we can use f of x and g of x, we should use them. We're writing the integral in as succinct a manner as possible. We don't have to show any other work. We just have to give the final answer. So that's what you will be graded on a calculator problem in the free response section. So if you need to take a look at that, you can. I'll close down the calculator. If you need to take a look at it longer, pause it here. Otherwise, I'll go on to part C. All right, in part C, we want to have a new function, which is h, given by h of x is kx times the quantity 1 minus x from 0 to 1. And if you spend a little time to consider it, you'll know that that h of x has to be all above the x-axis on the interval from 0 to 1. So it's going to be the top function here. And for each k greater than 0, the region not shown enclosed by the graphs of h and g is the base of a solid with square cross sections perpendicular to the x-axis. Now, this function kx times 1 minus x is going to have the same zeros as y equals f of x there. The question is just how high it goes or how low it goes. So it may, for example, look something like this, going up a little bit higher, or it may even be a little bit lower, if we drew that correct. And so we don't know what it is. K is going to affect the amplitude or how high that it's stretched up. We don't know about that. But what we do know is that the cross sections perpendicular to the x-axis are going to be squares. So all we need to do there then is set up a square. Well, we're going to take a particular strip between the two curves, and that's going to become the side of the square. And so all the other sides will have exactly the same length, which means that the square will have an area of h of x quantity squared, correct? And then it's going to have a little bit of thickness to it, which is also a dv. So if we added a little bit of thickness in there, that thickness would be a dv. I'm sorry, would be a dx. Would be a dx. And so the volume here would be the integral from 0 to 1 of h of x, it's not h of x. So I take that back. The area was not h of x quantity squared. It's h of x minus g of x quantity squared. And so the volume is going to be h of x minus g of x quantity squared dx. And we're going to integrate that from 0 to 1. And that's all we need to do there. Now we're told that for some value, there is a value of k for which the volume of the solid is equal to 15. So we would have that set equal to 15, and we are to write but not solve an equation involving an integral expression that could be used to find the value of k. And that's what we have there. It's the integral from 0 to 1 of h of x minus g of x quantity squared dx is equal to 15. And so that'll do it for this problem here. And you can pause the video if you want to look at this one a little bit longer. Otherwise, I'll go on to another problem.